AMC 2004, problem 16. The 5x5 grid shown contains a collection of squares with sizes 1 by 1 to 5 by 5. We're trying to find how many squares contain a black center square. Well, the easiest way to do this, in my opinion, will be constructive counting. We can do complementary counting, counting the number of squares that we don't want subtracted from the total, but that would be much more work, in my opinion. But you can take this either way, and there are many there are many ways to solve this question. But upon doing it myself, I believe constructive counting is the best way to go. We're told that the number of squares range from 1 by 1 to 5 by 5. So obviously, we want to write down each dimension that the squares that have the black square can be. So this should be the first thing that you do when you approach this question. Now, how many 1 by 1 squares contain the black center square? Well, obviously, they're just one. Likewise with a 5 by 5 square, because it's just a big outer square and the one inner square. So if we see that there's a symmetry between 1 by 1 and 5 by 5, could there be a symmetry between 2 and 2 and 4 and 4? And the answer to that is yes. Why is that? From the right hand side of the screen, you can see I copy pasted another graph at a larger scale for analysis. So we know that it's a 2 by 2 square. So where can a 2 by 2 square exist such that it will have the black center square? Well, from constructive reasoning, it will only be this square right here. This square that's within the inner 3 by 3 square, which is this square right here. It has to be inside this 3 by 3 square in order to contain the black center. So how many 2 by 2 squares are within this 3 by 3 square? Well, if you count it, there will be 4. So 2 by 2 squares will also have 4. And now, what about 4 by 4? Well, the 4 by 4 square is awfully similar to that of the recent one, the 2 by 2. The 4 by 4 is just here and here. The square, if you can visualize it and imagine it in your head, we just need to count the number of squares that contain the 4 by 4, and the 4 by 4 can only exist within the outer 5 by 5 square. So therefore, there is 4 of them as well. Now we're just left with the 3 by 3 squares. Now, the 3 by 3 square, we just mentioned previously that there's an inner 3 by 3 square that contains the black center, so it'd be 1 plus the remaining 3. Now, we can see here that there are many 3 by 3 squares that contain it within the outer 5 by 5 square, and all I need to do is count it carefully. And to do that, I'm going to copy paste this image again so that it'll be much easier for us to see visually. So now that we have it here, how many 3 by 3 squares are there? Well, there will be 1 right here, there'll be 2, there'll be 3, and there'll be 4, there'll be 5, there'll be 6, there'll be 7, and there'll be 8. So 1 plus 8 will give 9. Now you can see here that upon drawing it, it looked very, very messy. But if you're doing this on paper, just picture it visually within your mind. And I do apologize for the messiness, but when you're thinking about questions, it is often good so that you yourself understand it and so that you yourself can process it the best you can. So even if that means drawing a very messy graph, as long as you understand what you're writing, you will be fine. So now that we have the total number of squares that contain the black center square, just add up each case and we'll be done. So 1 plus 1 will be 2, 4 plus 4 will be 8, and 9 as a loner. 2 plus 8 will be 10, plus 9 will give 19. So the solution to this question will be answer choice D.